All right, so we are moving on through our circle lesson. We are now in chapter 10, section 2, and I have also broken this video down into a few separate videos. Again, like we started last lesson, I did a bunch of definitions. I am going to do the same thing here as well, and then I will go into the math portion of it. So I suggest printing this out or at least reading through the definitions as I go along, and then when I get to the math portion that you're either drawing it or writing the answers down for the notes, since as you can see, there's a couple math sections that I want to fill in. So to go through the definitions, when we talk about different arcs within circles, there's also different angles that are created. So a central angle is an angle that is created using different points on the circle, but their vertex has to be the center of the circle in order for it to be considered a central angle. So since the center of the circle is in the center, hence central angle. To name the angles, we have to be very specific as to what order we go in. We can't just list 3 letters. So this angle can be written as BAC or CAB. The vertex of the circle, the center of the circle, is always the middle letter. For a minor arc, what that refers to is a arc or a region of the circle. Now, the reason this red arc here, so see this arc sign, it's kind of like a little archway over the 2 letters, and M just stands for measure. So A to C are the 2 points I want you to focus on going through the circle. That arc is called a minor arc because it is less than 180. You know that it is less than 180, A, because it looks small, and B, half of a circle is 180 degrees, that whole arch. So if this arc is clearly less than that, you know it's a minor arc, and that's also why I put the degree is less than 180. For a lot of these angles, I will be giving you what the measure of the arc is, or I will show you how to find what the measure of the arc is, so you're aware if it is a minor arc or not. Now, a major arc is more than 180 degrees, but less than 360. So it can't be more than 360 because there's only 360 degrees in the circle. So from 180 to 360, we are looking at a major arc. Now, this one has 3 letters, and the reason for that is if I just said BC, well, I could be talking about this blue region here, or I can be talking about this red region here. So you need to be specific again when it comes to naming arcs as well, with the little arch symbol over it. So since I want to talk about the major arc in red, I have to name it as B. I'm going to go through point D, then C. You could have also named it CDB as well. You can't say BCD because that would mean I'm going in this left downwards direction. So be specific with the direction you want me to follow. So B, D, C forces me to follow along that red line. And clearly it looks like a rather large angle measure. So that is why this red is considered a major arc. It's clearly more than half the circle that is taken up as well. For a semicircle, that term I'm going to use frequently. It's just talking about half of the circle. So I put 2 comparison points here. The measure of the arc for a semicircle is always 180 degrees because it takes up in this green here exactly half of the circle. And then to compare how a semicircle is a little bit different than a major and a minor arc, a major arc is bigger than a semicircle. A minor arc here in blue is smaller than a semicircle. So you can have other smaller minor arcs within a semicircle, and a major arc would only contain the whole semicircle and a little bit more. To measure a minor arc when we are using central angles as we are here, it is the same angle measure of that central angle. So if angle APB is 50 degrees, then that means the measure of the measure of the minor arc AB is also 50 degrees. So if the central angle is 50, the arc measure that it opens up into is also 50 degrees. So that means this green portion that I'm showing you right here of the circle, it takes up 50 degrees out of that total 360 on the outside of our circle. To find a major arc, you're normally going to be given just the measure of a minor arc here. So we have minor arc AB, and I know that the minor arc A to B is 82 degrees because its central angle is 82 degrees. Now, if I want to know what ACB is, so the rest of the circle, what you do is take 360, because that's how many degrees there are in a circle, and subtract 82 from it. So 360 minus 82 is 278 degrees. So to figure out the major arc when you are given a minor arc or minor central angle here, you would just say 360 minus 82. And this is going to be the situation you would be given to find a major arc. So in this example, we're going to be able to find different arc measures, and here I have listed out 4 of them. We know that the vertex is this blue dot here, and in the directions, it's also important to point out that N through P is the diameter. So we have 2 semicircles, N, R, P, and N, M, P, because it's split down the middle. So each of those sections would be 180 degrees because they take up half of the circle. And then they also tell us that circle R, that's just the name, I guess, that they picked for this. I'm not really sure. So for MN, if I want to know the measure of this angle here, or this arc here, MN, I look at the central angle and see that this is 100 degrees. So that means the arc that it opens up to is also 100 degrees. And let me see if I can find the math symbol really quick. Please, for here on out, I know I wasn't stressing it too much when we were in class together, but I'd like you to start putting the degrees next to it. I won't take points off, but I just think some of you are not fully grasping that we're talking about degrees as opposed to some other type of unit. So try and include degrees from here on out. Now we're looking at MPN. So the rest of the major arc that doesn't include the minor arc we just solved for in part A. So if I know that we have 100 degrees taken up already from the minor arc, and MP to N is the rest of the circle or the major arc, we're going to follow the math that we saw up here. 360 minus 100, and quickly you should get that that major arc is going to be 260 degrees because that's what's left over. There are other ways to figure that out, but I'm going to stick to one method right now since we're not all together and I can't necessarily answer all of your questions. For PMN, so PMN, this is when you want to refer to the directions. It's very important. One thing I noticed is NP is a straight line, and we know straight lines have 180 degrees. So if you forget how to use that information as a semicircle, NP is a straight line, so that's 180 degrees. And I know that MN is a part of that section, which is 100 degrees. So what's left over here? 80 degrees, not 180. So we have 180 degrees in total on this line. There's 100 degrees right here. So that means this remaining central angle is 80 degrees. So PMN includes both of these central angles. I would have to add up 100 plus the 80 degrees that would be left over, and that's 180 degrees. I'm also hoping that you notice that this is a semicircle created here, so you wouldn't have had to do that math anyways. And then for PM, that's exactly what we just did. We have 100 degrees on this straight line NP, so that means this remaining central angle has to be 80 degrees. And if this central angle is 80 degrees, then that means this minor arc of PM is also 80 degrees. Now, the last bit of information is how we can use more than one arc or central angle to find other arcs. And they call it the arc addition postulate. I'm just going to focus on how to just add things together instead of using the rule. So it's in this circle. We see that we have 80 degrees as a central angle, 110 degrees as a central angle, 40 degrees as a central angle, and it might be helpful to start to find out what this missing central angle would be. So there's 360 all the way around, so I know I need 360 all the way around this vertex in the center of the circle. So I have 80 plus 40, I'm just going to pick those numbers first, is what, 120, and then we're adding 110 to that, so we're at 230. So that means we have about 130 degrees left over for this central angle here. So just to focus on what these are asking for, if I want GE, you find G all the way over to E. We are adding central angles together, hence the arc addition postulate. So I'm going from G all the way over to E. So I'm encompassing the central angle of 40 degrees as well as the central angle of 110 degrees. So 40 plus 110 is 150 degrees. So that means that all the way from G to E is 150 degrees. For part B, we are talking about G to E all the way to F. So that means we are adding up all three of these central angles because all three of them encompass this major arc. So once again, 40 plus 110 is 150 degrees. and then 150 degrees plus 80 more is 230 degrees. So you're adding up all the different central angles that comprise of this entire arc here. If we're looking for GF, we have two options, which is what I just explained before I found any of these. You could take all of these and subtract from 360, or you can see if there's other things you can do. I'm just focus on 360. So I have 40 plus 110 is 150, plus 80 is 230. We go back up to this finding the major arc method. So we have now 360 minus 130 that we added up here. So GF is what's ever left over, and we're going to be stuck with 130 degrees. And remember, there is 360 degrees in the circle, so we add these up to figure out how much more do I need to get to 360. Now for F, H, E, this is very important that you go in the correct order. F to H to E. Be very careful, because if I did it in a different section, I might be adding up the incorrect angle measures. So I'm going F through H to E. Now notice I want this entire major arc, all of it that doesn't include the 80 degrees. So one way we can solve this is saying 360 minus 80, because that's the only section that's not included. And we're going to get 280 degrees. Or you could have said 130 plus 40, now we're at 170, plus 110 and get your 280 degrees as well. So arc addition, you're just adding up the central angles that contain the arc. Major arcs are 180 to 360, minor arcs are less than 180, and a semicircle is 180. I know this is a longer video, but I know it's important to get all of these definitions down. So good luck.